Thanks, Marcus, and good morning, everyone. I'm Curtis. I work on the gameplay architecture in Unreal Engine, and today I'm excited to talk to you about the new gameplay framework for UE6, which begins with Verse. Now, Verse is a next-generation programming language, purpose-built to power massive, persistent game worlds at scale. We originally released it 3 years ago in UEFN, where we could grow it to become the foundation for UE6. And Verse draws ideas from functional, logic, and imperative languages, and it should feel immediately familiar to anyone who's worked in languages like C# or Python before. But it also has some unique features aimed at solving the complexity and scaling problems of modern game development, starting with this unique software transactional memory model, or STM. Now, all functions in Verse run as part of atomic transactions, which can be rolled back and re-simulated as needed. And this lets us do a lot of interesting things in our game's code. So for example, to check if an object can be successfully moved in the world, we can simply set its position, then do our spatial queries to see if it's hitting anything. If it is, we abandon the entire transaction, reverting the entire operation, and pretending the code never ran at all. Now, Verse's transactional memory model can also help us address another big problem in game development, building enormous worlds with larger player counts. And today, one of the big limiters to really building larger games comes down to server technology. Scaling a game to run on multiple game servers requires a fundamental rethinking of your entire game's architecture. Well, with UE6, we're working to build a full distributed software transactional memory system to address this. So here's the idea. We take your existing single-threaded style Verse game code, and then we distribute it across multiple servers. When an object's needed in one server, the Verse runtime rolls back the current transaction, migrates the object over to the server, and then reruns the transaction with the object now present. And this is all done in a way that retains the transactional consistency of the original program. And finally, with Verse, we wanted to make saving game data way simpler. So the Verse runtime can automatically synchronize and save any global state for the program, and then share it across all running instances of your game or an ecosystem. And to the programmer, what this means is that setting up something like save state for a player is as simple as setting a single global map of player to save state. No more having to set up databases or coordinate schemas between your game and other backend services. You can do all of this without ever leaving Verse. Now let's take a look at how Verse fits into the bigger UE6 gameplay architecture. So at the foundational level, we have the Verse runtime, along with all the UE systems that exist today, like rendering, chaos physics, meta sounds. With Verse, we're also introducing the Verse scene graph framework. Now, this is a modern game component framework with full support for prefab-style workflows and runtime composition. The scene graph has been designed to utilize all the power of the Verse language, including modeling the entire prefab data model through Verse's type system. Above this, every core system in the engine is exposed as concrete Verse objects. Each material, mesh, Niagara system that you author becomes a type of Verse class with a statically validatable API. This lets us use the Verse compiler to validate all of our data in a unified manner across the entire engine. For example, if you change a parameter in a particle system, you'll immediately know where in code needs to be updated to match. And finally, we'll be introducing high-level frameworks for common game systems like characters, weapons, and vehicles. Now, building with these frameworks helps speed up development, but it also creates content that can be shared widely across games and ecosystems. So imagine grabbing a car from Fab, and instead of simply getting a skeletal mesh and some animations like you might today, you get a fully working Verse module for a car that functions across all of your games. With the UE6 gameplay framework, we're envisioning a world where enormous amounts of code and content is being built and shared between these projects, with Verse providing strong backwards compatibility guarantees to help the ecosystem grow sustainably.